All right, chemistry for Monday 9/14. Starting a new unit, we're looking at measuring matter. Um, so dealing with numbers and with units. Any number in chemistry, or I should say 99% of the time, a number in chemistry is going to have a unit with it. If not, it's considered a naked number and it doesn't really have a lot of meaning. So those are the things we're going to talk about in this unit. So a new EQ, be sure that you go to your journal, put your date, and then answer your journal question. Remember that journal question is also available in your Google Classroom. So things that are going on this week, we'll have a quiz on Friday over measurements of matter, which is a unit that we're covering. See how far we get on it. Tutorials this week or tomorrow after school and Thursday after school. So if you failed the test last Friday and you would like to try to bring that up to 70, you can retest on one of those days. You only need to do an exit ticket that's in the classroom if you're absent from school. So whether if you're virtual or if you're in class, those are both considered present. You will not need to do the exit ticket. Our journal test is going to be next Tuesday or next Wednesday, so make sure that you are up to date on that. That is a major test grade. So if you have a low grade and then you failed that, that could bring you down to failing. And 6 weeks test, we're not going to have a cumulative test. We will have a test over what we've covered on this unit, but we won't have a test that goes back and also picks up matter. So it will not be cumulative. All right, so these are our notes, new set of notes. So they're in your Google Classroom, and it's called Measuring Matter Notes. So we're going to start off with a scientific method, which you've covered before. So scientific method is a logical approach to solving problems by observing, and collecting data, formulating and testing theories, sorry about that, y'all. I'm ahead of myself. This should be hypothesis. You have to have a hypothesis before you can get to theories, which is supported by data. So the only way we're going to get data is through experimentation. So through experimentation, we could observe and then collect data. So observations involves making measurements, and collecting data. Data may be qualitative or quantitative. Qualitative would mean it would be descriptive, like it's blue or red. Quantitative means it would be some kind of measurement. It would have a number attached to it. Experiments involve carrying out a procedure under controlled circumstances. You have to have controlled circumstances, or circumstances that would be reproducible, so that your data and then your outcome would be valid. So formulating a hypothesis, so generalizations. Or statements that apply to a range of data. And generalizations, I'm just going to put a ditto mark because it's generalizations again down here, are used to form a hypothesis which is a testable statement. It's often used as an if-then statement. If-then. If I add fertilizer to the plants, then they will grow larger. And then that's something we could do an experiment on. So experimentation is used to either support or reject a hypothesis. And many hypotheses are actually rejected. Some scientists spend their whole life trying to prove one thing. Okay, when we talk about theorizing, so a theorizing is bringing more than just one hypothesis. So it's bringing more data together to come up with a model or a theory that is then just kind of accepted. So a model is an explanation of how phenomenon, pH, E, that's supposed to be an H right there, y'all. Okay, so we'll start over. P, H, E, N, O-M-E-N-A, phenomena occur, and how data and events are related. All right. I had to pause it again, so I may be repeating myself. So theorizing is a model, is an explanation of how, I think I'm repeating myself, of how phenomenon, oops, that's supposed to be an O, P-H-E-N-O-M-E-N-A, occur, and how data of events are related. So kind of just really short and scientific, because y'all have had that before. So we are going to talk about units of measurement because they are so important in chemistry. A number without a unit is an incorrect number. You got to have your units attached. So a quantity is something that has size, magnitude, or amount. It is not the same as a measurement. So like the numbers you work with in math, those would be considered quantities. A measurement is going to be a number with a unit. I always say that in math, the numbers don't mean anything. In chemistry, they do. So the system that we use is the SI system, which stands for the System International. Kind of shorthand metric system. And it was adopted in 1960, and it has 7 base units. Standards have a constant value. So the base unit is kind of the beginning unit. And then from there, you move the decimal around. I know y'all have done that before in the metric system. And then the standard is something that can be compared to. So starting off with length, symbol L. This is your base. So the base unit is meter. Abbreviation M. Mass is little m, kilogram is the base unit. Kg would be your abbreviation. time, little t, seconds, or the base, abbreviation of little s. Temperature, big T, we use Kelvin, K. Amount, N, little n stands for moles, abbreviation MOL. You'll probably be tired of moles by the time chemistry is through. Electric current, these last two are really more physics. Big I stands for elastic current, amperes or amp, big A. And then luminous intensity, that's like how bright a light bulb is, IV. Candela, and CD would be your abbreviation. Like I said, those last two we really won't use in chemistry. We may use the electric current a little bit, but not too much. We also have what we call derived units, and that's a combination of base units. So where you end up having more than one unit with your number. So y'all all know volume is length times width times height. So if my length is so many centimeters, my width is so many centimeters, and my height is so many centimeters, not only do I have to multiply the number, I also have to multiply the unit. So I end up with a cubic centimeter or a cubic meter or meter cubed. Area, square meter, and then molar mass, little m. Our derived units will be grams per mole or G per m. Another one that we do, and we're going to be working with in just a little bit, is density, which is grams per volume. So you would end up with something maybe like, I'm sorry, let me change that. How not, instead of grams, let's make that mass divided by volume. So your units you would end up with would be something like grams per milliliter. Grams is a unit for mass, milliliters is a unit for volume. All right, put these over right here. So mass is defined as the quantity of matter of an object. Weight, on the other hand, is the mass of an object multiplied by the gravitational pull. So your mass would be the same here in the moon, but your weight is more here than it would be at the moon because we have more gravity here. Length measures the distance in one plane of an object. Volume is the amount of space occupied by an object. The SI standard is the cubic meter, which would be written as m cubed. But it's too large really for convenience, and especially what we do in chemistry. So we instead use the cubic centimeter. So cm cubed or cc. So cc is equal to cm cubed, which is the cubic centimeter. The non-SI is the liter. It has a volume of a decimeter, a deciliter, or a deciliter cubed. 1 cc is equal to 1 ml. Those are interchangeable, those two units. So if I have 100 cc's, I have 100 milliliters. So really our main volumes that we use are milliliters, liters, centimeters cubed. Those are going to kind of be our main ones. All right, let's talk a little bit about density. So density, the formula for density is equal to the mass to volume ratio. So it's going to be the mass divided by the volume. It's one of those formulas that fits nicely in your little triangle if you've ever used those. So I would have density is equal to mass, and here would be my V. So for mass, my units would be grams or kilograms. For volume, my units are going to be milliliters, liters, maybe centimeters cubed. So that helps you to know what you're looking for in your problem. So the first one, it says, what is the density of a block of marble that has a mass? So there it tells you right away. There's my mass with grams and a volume of 310. So my formula is density is equal to mass divided by volume. So this one, I'm just going to plug in my numbers. My mass is 853 grams divided by my volume, which is 310 cc's. So remember, whenever you do this calculation, this number first goes in first, your top number goes in first to your calculator, and you divide it by your bottom number. Now, unlike math, whenever we get our answer, we don't want it to have a whole bunch of places. You want your answer to have as many places as the numbers that you started with. So in other words, this number was 3 and this number was 3. So when I get my answer, I only want it to have about 3 places. And this has to do with something called significant figures. So if I took my top number divided by my bottom, I would get 2.75. And then my units would be grams divided by cc, because I had grams up here and cc down there. All right, next one, what is the mass of a 3.5 cc diamond? So since that has cc's, this is my volume. And there is my density. It tells me it's my density, but density would also have those units, grams per cc. So my formula for mass, if I come over here and I look at my little triangle, remember how that works. You cover up what you need, and then that tells you what you need to do with the other one. So if I'm trying to find mass, it's going to be density times volume, because they're next to each other. So density times volume. So once I do that, now just plug in my numbers. I'm going to say my mass is going to be equal to 3.26 grams per cc. Multiply it by my volume, 0.350 cc's. That number had 3 numbers to start off with, and this one did too. So I want my answer to have about 3 numbers. That's simply a multiplication. So I'm going to multiply them by each other, and I would get 1.14, and cc's, I have 2 cc's, so they would cancel out. So that means my unit is just grams, which makes sense because I'm trying to find mass. And we said one of the things that would be a mass unit would be grams. All right, and our last one right here. Why don't you turn the video off for a minute and give it a try? All right, I'm just going to come back here and make our little triangle. So this one says what volume? So now my unknown is my volume. Well, 76.2 grams, since that has a unit of grams, this is my mass. A mercury occupy, and there's my density. So I'm going to do the same thing. I'm going to cover up volume, and that tells me what I need to do, what math application. So I need to take meters divided by density. So volume is equal to meters divided by density. So now I'm going to plug my numbers in. Not meters, I'm sorry. Mass, too much teaching today. M is for mass. So I'm going to take my 76.2 grams, and I'm going to divide it by my density, 13.6 grams per cc. top number goes in your calculator first, divided by your bottom number, and we want it to be about 2 places. Let me pull my trusty calculator out here. Not 2 places, about 3 places. So we'll get 5.60, and once again, these grams canceled out. All I'm left with is cc's. So cc's would be my units, which makes sense because it's a volume. All right. So tomorrow we will continue on with that and do a little bit more density work before we start on our rest of our notes. So if you were absent today, be sure that you go and that you do complete your exit ticket. And we'll see you tomorrow.